Dr. Mihwa Na, and then we'll go into the Q&A section. And attendees, if you have any questions, please type them into the chat and we'll do our best to get to as many as possible. And now I'll hand it over to Mihwa.
Thank you, Lori. Are you seeing my presentation mode?
Yes, we sure are.
Okay, great.
Thank you.
Okay, hello everyone. Thank you for joining us today, and thank you, Nikita, for the nice overview of the safety assessment process, as well as the respiratory endpoint introduction. So I'm Mihwa Na, and I will be talking about how we take the tiered approach to conduct skin sensitization risk assessment on fragrance ingredients. So fragrance ingredients are ubiquitously used in products that come in direct contact with the skin. So it's important to assess whether they are skin sensitizers or not. And if they are, what are the safe use levels? And that's what the skin sensitization team at RIFM does, the safety assessment of fragrance materials on skin. And we would like to do that in the most sustainable way. And in order to achieve that, our strategy is to minimize the generation of new experimental data by maximizing the utility of existing data, the read across, and the dermal sensitization threshold, DST. Those are the three first steps that you see on the screen. We also lead the efforts in evaluating and applying the new non-animal methods for risk assessment for skin sensitization so that risk assessors from different industries can decrease their dependence on animal data. And when it becomes necessary to generate new data, we can resort to non-animal testing. So skin sensitization is an immune response that develops when you come in contact with skin sensitizing materials. It's usually marked by redness accompanied by swelling and/or blisters. And it comes in two phases: induction and elicitation. Induction is where a subject is exposed to the sensitizing chemical and your immune system starts to develop towards that specific chemical. I'm showing the exposure routes that are relevant to fragrance materials here, but skin sensitization can really be induced from metals, topical medications, etc. So during this phase, no skin reactions are seen, even if you're actually allergic to the chemical you're being exposed to. It can take a while to be fully induced, and anywhere from 3 days to weeks. It also normally takes repeated exposure to be induced. Elicitation is when you're exposed to the same chemical again after your immune system is activated towards that specific chemical. And this is where you see the reactions such as redness, swelling. And you would see these reactions come in 1 or 2 days after the exposure, and it usually takes smaller amount for the elicitation compared to the induction. So at RIFM, our goal is to prevent induction of sensitization so that people are protected from developing skin allergies to fragrance ingredients. We begin our skin sensitization risk assessment by thoroughly reviewing the data available on the chemical in question, as well as its structurally related materials. If the data on the target material is absent or insufficient, the data on the structural analog read across can be used for risk assessment as well. So where do we look for this existing data? We search multiple databases, including the European Chemicals Agency and RIFM database. RIFM database is a comprehensive source of regulatory, identity, and toxicological information over 6,000 materials, including 3,000 fragrance materials. So we rely on this database a lot. On these databases, these are the types of data that we look at. We look at historical human data, focusing on the confirmatory human repeated insult patch tests conducted following our published protocol by Politano et al. 2008. The question here would be to ask, are there any known incidents of humans reacting to this chemical? We also look at historical animal data, and these include guinea pig tests covered by OECD Test Guideline 406 and murine local lymph node assays covered by OECD test guideline 429. We also look at various in vitro data, the ones that have been well validated. These include OECD guideline studies 442C, D, and E. And each of these tests essentially address a molecular event that is required to develop the skin sensitization condition. We also look at in silico data. These tools, such as OECD Toolbox, can take the chemical structure and identify where the chemical has structural feature that makes it reactive to skin proteins. Based on all this data, our ultimate question is this chemical a sensitizer? We look at data from the target chemical as well as its structurally related chemicals, the read-across chemicals, to make this conclusion. If there's sufficient data to support that it's a non-sensitizer, we can conclude our safety assessment and say that it's safe under use. And I just wanted to note that we actually carefully evaluate our data that we use for this risk assessment process. We also publish the data that we evaluate so that the curated and reliable data sets are available for the scientific community. These are some of the examples that RIFM has published. And in these, we summarize the animal human studies that were conducted following our standard protocol, as well as in vitro assays. And so these data can be used by other safety assessors without generating redundant data on same or chemically related materials. For many chemicals, especially the new ones, it can easily be the case that we don't have sufficient historical human or animal data to determine whether it's a sensitizer or not. In those cases, most sustainable option would be to put more weight on non-animal predictive test data. So multiple in chemical and in vitro methods have been developed already, including the ones listed here. DPRA is included in OECD test guideline 442C, keratinescence in 442D, and so on. In the absence of historical human and animal data, RIFM currently uses the 2 out of 3 rule to identify whether a material is a sensitizer or not. So that's the hazard identification. And this approach is outlined in OECD test guideline 497. So if we have negative results from 2 assays out of these 3, we can conclude that the material is a non-sensitizer in the absence of any historical animal or human data. We recently evaluated USense data on 67 fragrance materials and found that this assay performs very similarly to HClad, and that we could use USense in place of HClad in hazard identification, applying the 2 out of 3 rule. So we use the available data that I've mentioned so far to decide whether a material is a sensitizer or not. If the material is identified as a sensitizer, we face another challenge because we need to figure out what the safe use levels are for those sensitizers, which depends on the potency of that material. A couple of in vitro assays that were developed to predict skin sensitization potency, such as kinetic DPRA, guard skin dose response, and senses, are available. These have not been fully validated though, and RIFM is actively working with our collaborators to evaluate the performance of these assays in predicting safe use levels in humans. So we've very recently initiated our collaboration with IFF and Sensigen in evaluating guard skin dose response assay. We also collaborated with P&G to evaluate the performance of senses, and this is actually published, has been published recently. So that's available open access. For the materials that are identified as sensitizers, we conduct a quantitative risk assessment to calculate the maximum acceptable concentration that can be used in different product types. Anne-Marie from RIFM collaborated with others, including the group called IDEA International Dialogue for Evaluation of Allergen, to publish the quantitative risk assessment method, which incorporates aggregate exposure and the appropriate safety assessment vectors to provide the maximum acceptable concentration of sensitizing fragrance materials. We call this QRA2, and this maximum acceptable concentrations calculated through QRA2 become the basis of IFRS standards. And again, here, the goal is to prevent induction of sensitization. And if you would like to learn more about this process, we have a webinar that's available on our website. The address is there on the screen, but maybe I can type that into the chat box after the talk. So for QRA2, Nestle is the point of departure. Nestle is the amount of fragrance material that can be used on skin without inducing skin sensitization. It's usually expressed in micrograms per centimeter squared. And based on this value, QRA2 provides how much of this material can be used in different product types. In recent manuscript in food and chemical toxicology, we described our dynamic process of determining this Nestle. And this process is very dependent on the quantity and quality of the existing data. So we provided various examples to illustrate how Nestles are determined for materials with varying data availability in this manuscript. If the data on the target material or the read-across materials are insufficient to conclude the safety assessment, we then look at the current exposure. As Nikita mentioned, we use the RIFM model to examine the exposure. Then we compare the exposure to the thermal sensitization threshold, which is DST, which is a level below which there's no appreciable risk of skin sensitization of an untested chemical. If the exposure to the given chemical is below the DST, we can consider that the chemical is safe under the current use level without further testing, whether in animals or in humans. So DST is a practical approach for risk assessment when the exposure is low. When we do use the DST for our risk assessment, we first look at the chemical structure of the material. The different DST values are used depending on the chemical reactivity. 900 micrograms per centimeter squared is used for chemicals that don't have the reactive features, and 64 for the reactive ones. RIFM collaborated with Cal to derive the DST values for high potency chemicals, which we didn't have before. So this work was published in Regulatory Toxicology and Pharmacology, and having these different DST values means that we have more ways to avoid further testing if the exposure to that chemical is low. In a recent review article published in Critical Reviews in Toxicology, we outlined which DST can be used and when, just to provide practical guidance. So next, I'd like to touch on how these DST values were developed. They were developed based on chemicals with existing animal data, specifically local lymph node assay data. The original DST values were derived from looking at 363 chemicals with known structure and with existing data. And here I just want to note that not all of these were fragrance materials, and they were chemicals used for various purposes that covered various chemical domains. What was important was that they had already available existing potency data. And 271 of these were sensitizers based on the animal data. And the potency values from these LLNAs were plotted, and the 95th percentile of that fitted curve was taken as a DST. So the DST values, in essence, are dependent on the data set. And because we utilize DST extensively at RIFM, we worked with LASA Limited to strengthen this data set that's used for deriving the DST values. We expanded the data set to 1,100 materials, and about 500 materials were sensitizers. And with this expanded data set, we re-derived the DST values for each reactivity category, and this work was recently submitted to Regulatory Toxicology and Pharmacology. But to summarize what we found, what we saw was that even with the data set that's much larger than the original data set, the derived DST value for each reactivity domain remained very similar to the original ones. So this result really reinforced our confidence and reliability in taking the DST approach. After trying to maximize the use of existing data and exposure information, if the conclusion can't be drawn, we resort to generating additional data. And this normally involves in vitro testing or confirmatory testing in humans at this point. So that was the brief overview of how we conduct skin sensitization safety assessment at RIFM. If you have any questions on skin sensitization risk assessments, please feel free to reach out to our skin sensitization team. You see, you see them on the screen. I work with Mara Lavelle and Isabel Lee, and we would be happy to take any questions that you might have.
Great, Mihwa, thank you so much.